Hi, I'm Rich with insideHPC. We're here at ISC'13 in Leipzig, Germany, and we're here at the CoolIT Solutions booth. Did I get the name right?
Yep.
Yeah, and we're here with Geoff. Now, Geoff, I want to start at the beginning because I'm new to your company. Who is CoolIT Solutions and who do you help?
CoolIT's been focused on doing liquid cooling solutions for the computing industry for almost 10 years now. We've recently transitioned from doing high-performance enthusiast-based desktops into servers and data center solutions.
Okay, so you were helping those overclocker guys that were trying to cook their machine to get the utmost performance. So there is some affinity there with high-performance computing right at the start, isn't there?
Absolutely. The whole mindset of getting as much out of the machine as possible is something we hold near and dear.
Okay. So what do we got here? What are you showing off?
We've got a variety of solutions that we're showcasing here at ISC. The first of which is a closed-loop solution, is what we would call it. It has a radiator built right into the server here. The benefit of this is being able to support a higher-powered CPU. Or potentially reduce the fan power that's being used inside the server. The benefits of which are just that. If it comes right down to it, it's just a better heat sink.
Sure.
In order to think of it in that scale. Mm-hmm. Next up from that is we've now done full manifolded solutions. So in various different form factors, small, meaning like we've got a 12U rack, a 25U rack, or 42 or custom racks are available. And by doing that, we're able to take all of the heat out of a server, whether it be just CPU, or in this case, we've done the CPU together with gathering the RAM heat as well. And we take that heat in the form of liquid and plug that into a manifold. And that manifold then is moving the water, the warm water, up to a heat dissipation mechanism, whether it's an air heat exchanger or we have liquid-to-liquid heat exchangers, and then it is consolidated and moved away.
Okay. So the thing about liquid cooling is, like pipes leak. What have you done to mitigate that thing?
Well, we've done our best to ensure that we're using proven technology. We have over 1 million of these systems in use today. The joining technology is a very robust, what we call FEP tubing. So this has very low water vapor transmission. It's incredibly durable. It's actually quite hard if you were to try and bend it or squish it. It's very difficult to do so. So we have little risk of damage or abuse, even resulting in a leak.
So what are we looking at here, Geoff?
Well, we've recently announced a partnership with Stobly, the world authority in dry break quick connects. So if you'll notice, they're all metal construction. We have these connections on our manifold, and they guarantee that it's not just drip-free, but actually dry when it breaks. So the philosophy is that we want to ensure that there's no special skills required in order to be hooking this up or disconnecting it for serviceability. Beyond that, we wanted to make sure that when a data center is going to invest in a solution with this manifold system, it's going to be there for years to come. So the manifold will probably last much longer than the server. And nobody wants to take any chances with liquid getting out.
Yeah, I mean, it looks robust, more like a hydraulic kind of fitting, like serious industrial.
That's where it has its roots.
Yeah.
Absolutely.
Yeah.
So the same sort of fittings that we would find on a fuel system on a Ferrari race car. This is the company that makes it.
Got it. Okay. So what else you got going?
Well, I can show you what it looks like in a full 42U implementation. We've got one right over here.
Let's go take a look.
So what you'll notice is the full manifold construction. We've got a high-quality stainless steel manifold with all those same quick connects that we made together with Stobly. And what you'll notice is that the manifolds are all very compact and fit just inside the back of a regular rack fitting. Up here we have a full quick disconnect system, such that if we were wanting to make a modification change it, go from one rack to another rack. It doesn't take any special skills to be able to actually hook this up and disconnect it.
So it's like a 40-some kilowatt kind of arrangement here? What do you think?
The capacity that we have on demonstration here is actually moving all of the heated liquid up into a air-to-liquid heat exchanger. So basically it's a giant radiator and fan system that sits just on top of the rack. The purpose of this system was in the case where a data center doesn't yet have liquid plumbed directly to the rack, we can make use of the advantages for increasing density, very high performance. We have huge capacity capabilities, upwards of over 40 kilowatts. And then later on, when they do get liquid plumbed to the rack, then we can upgrade to what we call a CHX product.
All right, Geoff, so here we are. Now, you were saying that once they do get liquid plumbed to the rack, you've got a way to bring that in a less disruptive kind of way. Is that what we're looking at here?
That's exactly right. What we have is our product called a CHX, so coolant heat exchanger. So instead of the manifolds being connected up to a radiator up top, we're now connecting it to a liquid-to-liquid heat exchanger. So the heat comes back from the CPUs. It comes here to it's a stainless steel plate heat exchanger, very high capacity, easily capable of, again, 40 kilowatts plus. And then we transfer that heat into the facility liquid, which is then exhausted outside of the building. So by using that system, our efficiency is incredibly high, just based on the fact that we don't need any compressive air conditioning. The uses of that hot liquid can actually be recycled into a building or just dissipated using dry coolers outside.